So we said that the function y is equal to 2 to the power x is an exponential. Where we are now saying that a which we are using there, now we pick a specific number, say 2. The first thing is, okay, so the first thing is, if we want to sketch this, suppose we're talking about sketching this guy. The first thing is, there is no value, okay? There is no value of x that can make y be 0. We don't have such a value there. Because if we do y to the power, if we do 2 to the power 0, this becomes 1. If we do 2 to the power 100, wow, this is a very big number. If we do 2 to the power negative 100, this is 1 over 2 to the power 100. As big as it is, it does not become 0. In fact, when you have a negative and the power is very big, it becomes very, very small, but above 0 in this case. Meaning, we can then think of, since we want to sketch, we'll use a table. Let's use a table of values. For example, we put x here, and then we'll find y. Let's pick values of x. Let's pick -1. Let's pick +0. This positive or anything. Let's put 0 and then +1 here. Okay. So we have 3 values of x. Maybe they'll guide us. What is y when x is -1? Okay, so the explanation, we're just saying here that there's no value of x that can make that y there to be 0. Okay, then we have picked numbers -1, 0, and 1. We want to find y when x is -1. So substitute when x is -1. We are saying when the power is negative, it's the same thing as taking this whole thing down with a positive power. 2 power 1 is just 2. So we put 1 over 2 here. Like that. Yeah, which is 0.5, but we don't want to deal with decimals. We'll just leave them as fractions. Then y is equal to 2. When x is 0, we get 1. So we have 1 here. Then y is equal to 2. When x is 1, we have 2. So we have 2 here. Then we can sketch it. So first thing we said, there's no value of x that can make this 0, meaning the graph won't touch the x-axis because this is where y is 0. And there's no value that makes it be 0. And then we have -1, 0, and +1. -1, comma, +half. 0, 1, and 1, 2. So we have points here, and points here. So this will be a curve of this nature. like this. So this is y is equal to 2 to the power x. Well, so this is just telling us that even if we didn't know what a is, I mean what this base is here, even if it was a function like a to the power x, the orientation will still be the same, provided a is greater than 0. The orientation will still be the same. The only thing that we won't have is that half there, and that 2 there will have 1 over a, and a on top where there is 2. So that if we want to deal with y is equal to -2 to the power x, then we will have x values, the same ones, we can use the same ones. What would be y then? So it's like just these values that we have obtained now, just bring in a negative. This will be -half, this will be -1, and that will be -2. So we put -half, -1, -2. Put here, and put here. So the curve will come out like this. So this will be the point there. So it's like it's been deflected along the x-axis. So this is y is equal to -2 to the power x. Well, so you can come back and say, oh, this can actually be y is equal to a to the power x if we remove these values, these ones. It can be called like that. So I put back the values because we are using a 2 like that. So we have 2. If we change the power of x to be, so remember here we have 2, we have a table. Yes, our plot. So we have this table here. Table of values. We also have a table here. Table of values. Meaning that if we do another table where we now fix y is equal to 2 to the power -x, then now when they are negatives, it's still positive, but just in the denominator. So we'll have a graph of this nature, which will be coming in this orientation, passing through at 1 and going up. So this one is for y is equal to 2 to the power -x. Why is the y function is not crossing the x-axis? Because we don't have a value that will give us 0. Because if it crosses, then we have the x-axis. We have the x-intercept. Now that value x, that makes this thing 0, is not there. There's no value that you can put here, and then this thing becomes 0. Now, what's your question? The hand is up. Oh, okay, cool. So if we give this guy a negative, if we say, okay, we want to deal with y is equal to -2 and the power is negative, then the orientation of the curve is going to be down here. So it will be down here. So this is going to be y is equal to -2 to the power -x, like that. So we have 4 families of these sketches, all of them not touching the x-axis. Okay. Now that we understand the relationship of exponentials, we understand that we can write this as a log. So let's see what happens if we write it as a log. So we were dealing with functions of this nature, y is equal to 2 to the power x. Now we want to operate with the reverse. What happens if we say log, if we say y is equal to log, let's put 2 first and say x here. We want to sketch this. When it's a log, maybe it's a bit complicated. So let's change it to exponential. How do we change? We say x is equal to 2 to the power y. So it means that when we form a table, what we know is y. So we'll pick the values of y. Now -1, 0, 1 are the values of y. And we want to find x. Okay. Again, we'll pick another one for y is equal to negative log 2x. This one will first divide the -1, divide the -1, and make it be -y is equal to log 2x, and then write it as x is equal to 2 to the power -y. Another table, so we'll have y values, then we'll pick -1, 0, 1. So we'll be looking for the y, for the x values. In this table, we'll be looking for the x values. Then we'll come back here again. And look for the x values. So we start the first one. What is x when y is -1? Second table. No, this table, no, I haven't filled in the tables. We'll just use this table with this function. So we just have 2 different functions. That's why I have 2 tables. So if the function was initially, this table is for the function y is equal to -log x. log 2x. So we're saying the negative you divide first and then leave the log as a positive, then do the lifting of 2 to the power y is equal to x. So we got the first table. When y is equal to -1, the value of x is going to be 1 over 2. So we'll have 1 over 2 here. And when y is equal to 0, the value of x is going to be 1. So we have 1 here. And when y is equal to 1, the value of x is going to be a plain 2. So it will just be 2. If we got the other one, what is x when y is equal to -1? Remember the function has -y and y is -1. So it's coming with its own negative. So it becomes 2 to the power negative times negative. We just get +1, which is 2. So we'll have a 2 here. X is equal to 2 to the power negative when y is 0. It's the same thing as 2 to the power 0, which is 1. So we get 1. X is equal to 2 to the power negative when y is +1. We'll have a 1 here, so we'll get half. So we have half. Then we can sketch. Yes. So put the sketch here. So we'll put the sketch here with what we know are the values of y first. This is 1, 0, and -1. The first one, -1, half. So we have half here. So we have a point and 0, 1. So we put a 1 here. We have a point here and another one, 2, 1. So we have a point here. And here again, there is no value of y that we can put here and make this whole thing 0. So x will never be 0. So it means that in this case, this is the asymptote. And then the sketch follows. So it's not touching there, goes this side like this. So this is the sketch of y is equal to log 2x. And then the other one, we'll put it in blue. We have -1y, 2 here, and 0y, +1 x, and 1, half. So the graph again, not touching the y axis. It will go like this. So I don't need to move that point there so that I don't force my graph to be bad. So this is happening at 1. So this graph is the graph y is equal to negative log of 2x. And so if we get the reflection of these graphs, so the reflection of these graphs will be y is equal to the log of 2 negative x. This is when you change this, it will be 2 to the power y is equal to negative x. So x is equal to -2 to the power y. meaning we are reflecting the first one. So the red one, if we reflect, it will take which form? It will take this form, where this guy is going to be 1 still, so it will be -1. And then this will be -½ and -2. So this curve is the curve y is equal to the log of 2 -x inside. Why is it not? Let me start with why it's not crossing the y-axis. It's not crossing because we are saying there's no value of y that will make this x to be 0. There is no number that when you put here as a power will make this 0. This can never happen. Because it can never happen, then the y-axis becomes the asymptote. The same thing with the other part. And then we now want a form which has both negative outside. So we have another one which would take this form. So this is going to be y is equal to negative log 2 negative x. So what happens is this. If you are given in log form and you have forgotten the family shape, you quickly convert the log to exponential, because with exponential, you can use a table like this one. You can use a table like this one. Just keep in mind that if y is the power, then the values you get are for y. If x is the power, then the values you get are for x, and you're finding y. That is the secret there. So we have these shapes. So these shapes will remain the way they are, but there will be shifts, just like you saw the absolute value functions being shifted, the trig functions being shifted. Here we also have shifts that we'll be doing. But if we use the table, we won't even see that there was much shift here. The table will be doing everything for us. This is a very, very good thing. All we need is to understand the properties.
Sorry, sir. Once more, you said why is it not crossing the y-intercept?
The y-axis. Because there's no value of y that when you take, there's no value of y that when you put here where there is y, this guy is going to be 0. This never happens.
Okay, sir.
Yes. Okay, so we say that y is equal to log 2x is the same thing as x is equal to 2 power y. Meaning, if we had log e x is equal to y, then the function could be x is equal to e to the power y. Something like this. So it means that the letter E is just, now E is not necessarily a letter in here. In mathematics, this E that is used in exponential, if you punch in the calculator, it is actually a value, 2 point something. So it's different from A, which we just say A is some constant. E is a specific constant. So where you see E, you don't even need to be worried. The shapes will not change. The only thing that will change is that, for example, in this question, you won't see this half here. You won't see this 2 here. If you are using E, this would have been E and this 1 over E. It would be like this. So please keep these families. Look at the first one as well. Keep these families. And then I'll give you today to look at them so that tomorrow we'll come and look at the Tero sheet 6. Using those properties that we listed in the first class and these shapes of graphs, when we meet tomorrow in that 1 hour, we'll finish the Tero sheet because what we've done here is more than what is in the Tero sheet. So please don't keep this. Go through the properties, go through this thing, try different numbers. Where I was using 2, try to use 3, try to use 4, and see what is happening. So when you're studying, you don't limit yourself. You try to do like, what is y is equal to 3 to the power x? How does the function come out? How does the graph come out? Okay, what if I have y is equal to 4 to the power x? Is there a difference? Okay, what if I have y is equal to log base 10 x? Is there a difference? Okay, then now let me attempt a log ex, where I don't know this e thing that is not known. Okay, what if I just sketch a general one? Suppose I have the base is a and I have x, so I'm dealing with x is equal to a to the power y. How does it come out? How is the orientation? Okay, of course, you limit a, you say I want a to be positive this time around, or I want a to be negative this time around. Try everything, try anything you can do and see what happens. In other words, I'm saying the topic is done. So tomorrow we're looking at the Tero sheet so that you can understand the topic very, very well.
So did we already do inverse trig functions?
No.
We're not going to cover that one.
We just mentioned them indirectly, but we'll get back and do the graphs of inverse. First, I'm giving you time to follow the trick. But once you have understood it for some time, then we'll come back and do the inverses.
Oh, okay.
Yeah. So like today, I give you time to go through these things so that when we come tomorrow, it will make sense to finish the whole Tero sheet because the topic has been summarized. And there's nothing more that you can learn in this topic apart from these things. So you have a good night.